Hello and welcome to Averages and Frequency Tables with me, Bill Henning. Now the objective of this session is to start at level 1 with group discrete data and represent group data graphically, find the mean and range of a set of quantities. We'll move up to level 2 and calculate the median and mode of a set of quantities, estimate the mean of a group frequency distribution from discrete data, use the mean, median, and mode and range to compare two sets of data, and anything else that comes up. When dealing with data, it is sometimes easier to group the data into separate classes to make it easier to manage and view. Now, if you're grouping data into classes, it's important that none of the classes overlap and they cover all the possible values from that data set. Now, a tally chart is your starting point when collecting data. Imagine you have to collect a survey and you have to stand and get information that you collect yourself. This is called primary data. Now, if you get your information from somewhere else, like a website or something like that, that's called secondary data. Okay, so let's show you how we use that. Now, here's an example. A tennis club records the number of aces hit by 20 players over an entire league season. Now, the recorded values are, and this is your data. This is called your raw data. Now, you may want to take that information and present it to a room full of people, could be professional, something like that. So you wouldn't just stand up there and talk about these numbers because it wouldn't mean much thing. So you want to present it in a more aesthetic way. Okay, and for this, the question may say, put these values into suitable groups. Now, when this happens, you have to look at your data, you have to look at the numbers, and you can see the highest value there is 46. Okay, so that tells you could probably break that into 5 groups of 10. Okay, and that's what it means by suitable groups. Now you can see on the left hand side here is your groups and the right hand side is your tally. This is also known as, could also be known as your frequency, and we'll do that. We'll deal with frequency in a minute or two. All right, so what you do is you create your groups, okay, and you can see there based on your data, your raw data, you've got up in values of 10. And remember, it says there don't overlap. So if you finish off at 10 there, you start at 11 on the next group. Because if you put 10 in here and you got the answer, number 10 come up, where would you put it? Which group would you fit it into? See, it becomes a problem. Okay, and then your final group, you always put over if you can. In this case, 41 or more. Because somebody could have scored 50. You never know. All right, so that's how you do that. And your tally. And the biggest mistake that a lot of learners make is they rewrite these numbers in these rows here. You don't need to do that. You use something called a tally. Okay, and you can see the tally, you just have a strike for every number. So for every number that falls within a group, you just put one strike in. So for example, this 22 would fall in this group 21 to 30. So you just put a strike. Okay, and that's what you do. In every fifth strike, you just put that angle in there like that. So that's what you do for that. Okay. Now, a frequency table would be useful to organize this data into separate classes or group. And there's your information, there's your tally chart, just like before. But normally during exam questions and mocks, you don't normally see this tally part. What you would see is something called a frequency table. And all the frequency table is this information here in numerical form. And you can see there's your frequency column. All right. Don't get hung up with that word frequency. It just means how many times a number appears within that group, just the same as your tally. Okay, and if you go along your data there, you can see there's a 6, there's a 2, there's a 4, and there's an 8, and that tells you there are 4 numbers within that group there that fit into the group 0 to 10. All right. Now that's important later on when you have to work out the mean and stuff like that when you're working with frequency tables. Now frequency tables are super important because they can be valued up to 6 points in your maths paper. Okay, and 6 points is worth 10% of your score just on one question. So it's worth investing time in frequency tables. Now you may think that your frequency table is not a great way to display the information if you're, say, presenting it to a room full of professionals. You want it to look as good as possible and as professional as possible. So you may want to take your frequency table and convert it to a bar chart. So how do we do that? Let's have a look. Right, there's your group and there's your frequency. All right, let's put that into a bar graph and see how it looks. There's your bar graph. Okay, and all you've done with this information, you can see the number of aces or your groups, your groups this column, always goes along the bottom. Okay, and your frequency, right, how often something appears within a set of data, always goes up the side. Okay, and don't forget to give your bar graph a title and label to tell people what these numbers and groups mean. Okay, and that's how you do that. So you can see that the number of aces goes along the horizontal, and make sure you spread them out. All right, don't be guilty of putting them all in the corner. And your frequency column goes up the side there. And that there is the perfect bar graph created from your original frequency table. Now let's look at mean and range. The mean is a measure of average values of a data set. The range is just a measure of spread. So let's have a look at that. Now Ryan measures his height and the height of 6 of his friends. Their heights in centimetres are, and there's your raw data. Okay, you can see the raw data, it's got that raw data. Now we have to calculate the mean. Now in maths, when they talk about the mean, they mean the average. There are 3 types of averages, and we're going to go through these in this session. But if you get a question where it just says the word average, then the mean, okay, it's just a mathematical term for the average. And you can see the average, you just add up all the values there and divide it by how many there are, okay. All right, so it's a total value divided by the total number. So if you add all these numbers up, you can see there you get 1127. Now here's a little tip at this point. Now if you've done BODMAS before, you'll know that if you add all these up and you forget to press the equal sign, if you divide that by 7, all the calculator will do is divide this number by 160. Okay, it won't divide it by 7. Okay, so it'll just divide this number, my apologies, by 7 and not this number. Okay, so you have to press your enter sign before you divide. Okay, and so 1127 divided by 7 is 161. And if you look at the data, you can see it's a number somewhere in the middle. Now let's look at find the range. The range is often known as a variation as well. We get this in a lot of questions, the word variation, which confuses people, but it's just the range, the difference between the highest and the lowest. So what you do is you rearrange from left to right and from small to large, and that's the same data that's up there. And you can see that the lowest is 153, the highest is 173, so the range is the spread of the data, how far it's spread out, and it's that number in between. Now we'll have a look at a range in the next slide. Now here's a great visual way of understanding how range works. We'll have a look at these 2 salespeople, okay? And you can see this first person here has a range of sales. Now remember it's in thousands, so from 3,500 to 4,500. So that tells you they have a range of 1,000, okay? And if you look at this second salesperson, you can see that ranges from 1,500 up to 4,500. What that means is you can see that this range here is fairly consistent, whereas this one here is all over the place. All right, so you would say that salesperson A is the better salesperson because their sales are more consistent. Okay, and that's what it means. The lower the range, the more consistent the data, and the higher the range, the more erratic that data. So therefore, the consistency is the key to understanding range. Okay, that's a word they're looking for in your question paper, consistency. Now we can use averages when making predictions, right? You have to make assumptions when making predictions. That's the only thing. Okay, for example, Jordan spends £120 on food in January, £220 on food in August, and £200 on food in November. Now calculate the mean to estimate how much Jordan spends on food in a whole year. All right, so you can see here, you take the 3 months, add them together, divide by 3 to find the average for 3 months, which is £180. Okay, now assume that Jordan spends £180 each month. Remember, now it's on an educated guess, it's not an exact science. Okay, we then estimate the total amount for Jordan spends on the food in 1 year is 180 times 12, and that gives you £2,160. So that's how we can use averages to make predictions. Now, we've covered the mean and range, right? So the mean is a measure of average value of a set of data, and the range is just a measure of spread. Now let's look at some other types of averages. Now Ryan measures height, and there's his data again, okay? But this time the question will say find the median, okay? So what is the median? Well, you just rearrange the data from left to right and from small to large, just like you did with the range, okay? And it's the number bang in the middle. All right, so as you can see there, if you rearrange that, you can see that the middle number is 160. Okay, now what if you've got two middle numbers? Okay, which can happen quite often. All right, now if there are two middle numbers, then you just add these together and divide by 2. So you can see there that the 160 plus 163 divided by 2 would tell you that in this case, the median is 161.5. Now I'll show you in a second or two when would you use the median and when would you use the mean, all right, when this part's finished. Now find the mode or the model. You'll see it called the mode or the model. The most important part to remember, this will help you remember, the mode or the model is the number most often seen in a set of data. So both start with MO, the number most often seen in a set of data. Okay, so again, you rearrange the set of data from left to right, small to large, and you can see in this case that the most common number is 160 because it appears twice. All the other numbers only appear once, so the mode is 160. But remember, you can always have more than one mode. All right, there could be 262s, for example. Okay, and when you get more than one mode, which is quite common, then these are called bimodal. Right, when would we use these types of averages? Now you may be given a set of data and a question and be asked to select a suitable average. So what average would you use to select? Well, it depends on the data. All right. Now if you look at that data, let's say for instance we work out the mean. So this set of data uses a mean, but is it a suitable average? Let's have a look. Okay, so you can see there that add it up, 473 divided by 6, and you can see that the average or the mean, average and the mean are the same thing. Okay, it's 78.8. Okay, now is it suitable? Would median do? Well, let's have a look at the median and see. So again, you would rearrange your data from left to right with the median, and it's the number in the middle. So the same data has some extreme results. And you may not want your audience to see these extreme results, because if you think about it, look at these results here. They're all fairly uniform, but look at these extreme results here. Now you may not want your audience to see these, and that's why you would use the median, right? And you can see with the median, right, it's the number bang in the middle. So you add these both together, and you can see now that you have an average of 109.5. Now that's the difference between the median and the mean. You have to look at your raw data because remember it's all about the data, how you interpret it. If there's extreme results and you don't want your audience to see it, then use the median. All right, but if your data is fairly uniform, there's nothing too extreme about it, then use the mean. Okay, and that's your answer to it. All right, you would use the median because they're extreme results you don't want people to see. All right, and then you have the mode. You can see there the mode. This is for things like colours or sizes when dealing in stock. An example in this case is dress sizes. That could be the sales, for example. That could be a daily sales for a day, and you want to order stock for next week. And you can see that the size 14 is almost 50% of your stock. So when you order stock for next week, you're going to stock almost 50% size 14 because that's the most popular size that sells. Okay, so that's the main differences. If you're ever given a question, pick a suitable average, it's usually just between the mean and the median. In that case, you have to look at the data. Are there any extreme results? If not, then the mean. And if there is, then the median. But again, when it comes to median and mode, they will tell you, they will mention median and mode in the question. If it doesn't, then it's the mean. Right, when we want to compare two similar sets of data, there are a few things to consider. So for example, this table displays the sales data from a car dealership across 2 consecutive weeks. Okay, now we're often asking in exam papers to make comments about these types of tables and graphs and things, and this is where averages come in their own. You can make certainly make comments about the mean and the range and stuff like that. So if we want to compare the sales data across the 2 weeks, we might want to consider the average or the mean number of cars sold each day. So you can see in week 1, if you add it all up, you can see and divide by 6, the average is 14. All right, in week 2, add them all up again and divide by 2, and you can see the answer is 16. So week 2, you can infer that the average number of cars in weeks 2 was greater. All right. Now, if you're doing level 2, mention the difference between the two. You will always be asked in maths questions to explain your results or your workings, all right? And the best way to do that is mention the difference between the two. So you would say something like week 2 is 2 points better than week 1. Now let's look at the range. The range is not a type of average, but it's still useful when comparing data. The range is the difference between the largest and smallest values in a set of data, or the variation. So it tells us how spread out the data is. If we consider the example of the car sales again, you can see there that in week 1, it has a range of 4. So 16 minus 12 is 4. And in the second week, you can see the range goes from 25 down to 10. So therefore, the range is smaller for week 1, so we can say the data is more consistent. All right, so you can see that data there. It's fairly uniform. All right, it's fairly consistent. Okay, and all of a sudden, second week, again, the data has a couple of extreme results. It's got this 10 here, and it's got this 25. Now, that could be anything. That could be a sales drive or something like that. This could have been some problems with the business. It may have shut down for half a day or something, depending. It could have shut for training. There's all sorts of things that you can infer from that table. But look how the average and the range help you make up some information that could relate to that data. So keep that in mind as you go forward. Another thing you may be asked to do is find the mean, the mode, and the range from a graph. Okay, again, don't be fooled, this is straightforward. The mean, all you do is you add up all the totals in the graph there, you can see, and then just simply divide it by 4, and that gives you an average of 13. All right, so you just add up all these totals, divide it by 4 because there's 4 of them, and then you move on to the mean. Now the mode is the one that's more popular, and if you look at that, all you have to simply see there is the walk is the most popular. You can see by the size of the graph, it's the biggest, so therefore it's the highest value. Okay, and that gives you a mode of 22. And the range is just the highest minus the lowest. So you can see 22 minus 8. All right, and that gives you a range. So you can see when you're presented with graphs and charts, the averages can really help you interpret what these mean. Because again, some learners find it a struggle to interpret graphs and charts. And boy, what a great way to do it by mentioning the mean, the mode, and the range. All right, so keep that in mind. Now this brings us on to frequency tables and how to calculate the mean, right? This is an area over the last 3 or 4 years I've been monitoring, and most students get it wrong because they don't understand how it works. All right, so examine the table below showing the merchandising sales and answer the question that follows. What is the mean amount spent on merchandising? Now, the biggest mistake people make is they add this column up, add that column up, divide one by the other. But that's not how it works, because if you think back to your raw data, and if you had to rewrite this data back to its original form, you would have to write £10 25 times. You would have to write £5 30 times in your big long list of raw data. All right, because remember we put them into groups. Well, with this here, we have to ungroup them, okay, to work out the average. All right, so this is how it's done. We have to create a third column. All right, and we get that third column by extending out the item price multiplied by the frequency. Because remember, this is your frequency column. There's your groups. There's your frequency column. This is just the price. Okay, so what we do, you can see we do that by multiplying and extending it out. So there we go, we've created that third column. Now watch what we do. You add up the third column, which comes to 1850, and you add up the number of sales. That's your frequency, that's your raw data. That's how many pieces of raw data you had, in this case 125. So if you think about it logically, there's your raw data, right? And that's the value of that raw data based on this information here. All right, then you just simply take 1850, divide it by 125, and that gives you the average. So you can see there the average price of these items is £14.80. Now that last one was relatively easy to extend out because it's something called discrete data. Discrete data is just a number you can work with, a solid number you can calculate. Now let's look at a different type of question, okay? Now a photographer increases the price he charges to print photographs. He wants to know if this affects his sales. Last week, before the increase, the average number of photos ordered was 12. This week's the customers ordered, and there's your frequency table. Okay, and now you can see the difference now. That has a continuous number there. Okay, there is no solid number you can multiply to create this third column. Now, before we move on, we have to find out the mean. But you'll see in the question it doesn't mention the mean, it just says the average number. When that happens, they mean the mean. So that there figure there is the mean from last week. All right, so remember when they don't mention what type of average in the question, then they mean the mean. And so you have to calculate the mean from this. So how do we do that? Right, let's continue with the question. You'll see how it develops. Now it says here, does the price increase seem to influence the number of prints ordered per customer? You would think if they put the prices up, the sales would drop, but let's see. And it says explain your answer, okay? Now the first thing in this type of situation is you have to find the midpoint between these two numbers. All right, so if you add 1 and 10 together, you get 11. 11 divided by 2 is 5.5. 11 and 20 is 31, divided by 2 is 15.5, and so forth. So what you do is you find the midpoint of your photos ordered in this case, all right, to turn this number into a solid number you can work with. You now have what they call discrete data, a solid number, and then you can extend it back out, okay, to your third column. You can see there's the values once you've extended out, and then you follow the pattern as the same table as before. You add up your third column, you add up your frequency column, okay, and then you simply divide one by the other. And you can now see that although the prices have went up compared to last week's average, the sales have went up as well, okay, and so therefore your explanation is relatively simple. It's no. After the price increase, sales have risen by 1.1 on average. Okay, and this is another example where you have to explain your answer by mentioning the difference. All right, so this week was 13.1, last week was 12, and you can see the difference, right? The reason I mentioned that, they can be, when you have to explain something, it can be worth up to 2 points. And if you leave that box blank, after doing all this fantastic hard workings, you're going to lose 2 points by not explaining the difference. So think on it every time you see are asked for an explanation in any question. All right, think about comparing data or mentioning the difference. Now, finding the median from a frequency table, this very rarely comes up in an exam paper. I've never ever seen it, but you never know. It's in the curriculum, so it may come up. All right. Now the table shows the ages of under 21 rugby squad, and it says find the median age. Well, what you do is you total up the frequency column, right? And you can see there, add it up, comes to 23, and you add 1. Okay. Now 24 divided by 2 is 12. So you take that value, 24, you divide it by 12, and then what you do is you find the 12th value down from the top of the frequency column. Okay, so you start here and you count down 12. So there's 5, 10, and so 12 must be in this row somewhere. So 20 is the median. All right, so you'll see that you follow it down to get the 12th value. The median age is 20. And that's how you find the median. And the mode, right, to find out the mode from a frequency table is relatively simple. It's just like the graph. you look for the row with the highest value. Okay, so to find the mode, you just simply look for the highest value in the frequency column, and you can see that the highest value there is 9. So the age 20 is the mode. All right, remember the mode or the model is a number most often seen in a set of data, and in this case, the number 20 or the age 20 is seen 9 times, and you can see that's the highest value of the whole lot. And that is averages and frequency tables, so I hope that helped. Thank you.